Hi everyone, welcome to ST Skills. This is a weekly system design session. We have a mock interview on one week, and the other week we discuss on one of the system design topics, deep dive. So this is one of the deep dives, and today's topic is distributed message queues. So today, Asim, Bhavesh, and I may also be discussing on distributed message queues, and feel free to chime in and provide your inputs as and when you want to share something, so we can make this as a collective discussion and learn from each other. So
Yeah,
yeah.
I think this is not like a
Mhm.
this is not like an interview, so anybody can chime in.
Okay, let's
Yeah,
start. Yeah. So do we want to do it like a system design solution, or like in general, like how we want to proceed?
I prefer doing a system design solution, like follow the format
Mhm.
and try to like how it could happen in a typical interview, but without considering like we have 45 minutes or an hour, we can use time wisely, but we
Mhm.
can spend more time if needed.
Okay.
Like that is
So
my call.
yeah, I think yeah, we can go. I mean, like so that it will benefit everyone if we proceed like the same approach. So,
Uh-huh.
so do we want to start with requirement?
Okay, so Bhavish and Naga and everyone. Okay, let's do it.
Yeah.
Okay, even if anybody wants to type, feel free to type. So generally, in any system design interview, we get with requirements. So this is like design distributed message queues. So why we are trying to build distributed message queues?
So first, I think it's because it's asynchronous.
Okay, async processing.
Yeah.
And it provides scalability.
Okay,
Performance.
We
What
can
do you mean by
even
performance?
Performance is like it's a reliability actually.
Yeah.
So
so
basically, it's the correctness message never lost.
Yes.
okay.
So I
So
think it's reliability. Like
Reliability.
performance depends on how we have the
Yeah, that's correct.
assuming part. Yeah.
so okay. Is the performance and scalability comes in Y, or that would be the characteristics of the system
Yeah, I
or
think we
requirement?
need to make this in non-functional, right?
I
I
see.
mean,
Okay. Yeah. Yeah.
okay. But why? Again, my question is why.
Yeah. So
oh, okay. If you
yeah.
are
One is
mentioning why, yeah.
if
To implement event-driven architecture,
No, again, like why event-driven architecture?
because it has low, latency, and
Low latency I can do with synchronous communication also.
Yeah, it's not about low latency. I think mainly about, I mean, like with synchronous, you always have this chance of failures, but like here you don't lose a message. So even though, I mean, like though you can process little later, but you always have the message at least once. So some
Yeah.
guarantees is there, durability, I think.
And what I can think is like if the both sender or receiver, if both are not alive at the same time, right? Sometimes receiver may be down, but you want to hold the message somewhere. So message queue provides that mechanism basically.
What
Hold
what
on.
what are the differences between the message queue and distributed message queue? Because with a single message queue, we still can do async
So
communication. Right?
distributed in the sense like your nodes or servers like can be in the cloud, right? So anywhere. So I mean, like if a normal message queue, it'll be like you have one server and only like within an internal network, internal company network, you can have your own message queue that is dedicated only for your company and only within your local LAN network and not outside your LAN, and it will be accessible only there. I think distributed, I mean, like, I think as the term says.
So I think we should park it for a second. And when we'll talk about load and messages, then automatically there's no other way to go distributed. But coming back to the same question, why? So basically, we want async processing. We want to hold message, like Naga mentioned. There are different, I think, terms, but at least once it should deliver.
Guarantees, yeah. I mean, like.
And if there is some error processing, then we could also always have something, a way to monitor, like something gone wrong.
I think monitoring is there still on the synchronous for failures, but I don't know, like, so maybe we can collect other what a message queue should do, and then we can get back to this.
So
shall we add editing? Like someone want to do audit, how many messages communicated between the process or a period of time?
Sorry, I didn't get that part.
Now, what I'm saying, like for company who has the auditing requirements.
Okay. Let's go to requirements, but here let's not spend now too much time on why. But basically, my point was in a typical world, how we used to do is that we have two things which are communicating each other synchronously. It could be like a REST based, let's think. So this person could send too many requests to this person, and this person is not ready, and we don't know in real world how things could go. Then why not, if this guy is a producer and this guy is a consumer, like producer would produce some stuff, put that in a message, and consumer can consume on the rate it could and consume asynchronously. So again, it would be a design decision where you want to put a queue or not. But this is typically like a producer will put messages, consumer will. Otherwise, they can even talk directly.
And if there are multiple consumers, right? One pub sub model with multiple consumers. So the publisher doesn't have to send it to everyone. So once it sends it to queue, then all the other consumers can pick it up as and when they're ready.
So let's have this discussion for now. Keep in this scope, like there would be only one consumer.
One consumer, okay.
Yeah, for this discussion.
Sure.
No, but I think it's a good idea. Like, why do we need that? Because that queue can be used to implement PubSub model. That could be one of the things, I think. I mean, it's for this discussion, it's fine, but that's like, why
do we want like a point to point, or like PubSub? Is that the discussion, or like one to one? Or
so this discussion I am considering in terms of how SQS is built. And there also it is not multiple consumers.
And I think in the requirements, we need to consider, like, do we need order or not?
Yeah. So let's now get to that. And yeah.
I think another one I could think of is queue size.
So then we need to put. So we need to put that also as requirement, right? If you want only one client, then we need to add that in the requirement. Maybe later on that may be multiple.
Yeah, I just added.
Yeah.
Asim, I just put some questions you can fill in like as we discuss.
Sure. Bhavesh, your thought on this?
Yeah, I think we capture main requirement is somebody can send a message and somebody can receive the message, right? That's the main requirement of the queue. Now, I think all other things, yes. So order and all, maybe, yes, that is good. But I think we have covered the main requirement. So somebody should be able to send message, somebody should be able to receive message. Producer and consumer. Yeah.
So we have multiple producer or only a single producer?
I think it
Consumer receiving. Oh, yeah.
so by characteristics it should not matter, but if we want to capture as a design, I guess we can say that it will support multiple of both, because again queue is a bucket, right? Where if you have if you are authorized, you can publish. It doesn't matter how many are publishing into that bucket, and if you're authorized, you can receive. It doesn't matter how many are on receiver side, right? Consumer side.
But like, yeah, but even the multiple producer and multiple consumer, but potentially we still want this consumer want to send this message to, and not this consumer only, right? We're not broadcasting. We just say one-to-one.
So I think that is correct. The thing is that what we are saying is that we should be able to define a different queue, right? So that means for a set of consumer and receiver, set of producer and consumer, basically there is something queue is defined. So anybody who is sending to, let's say, Q1 and anybody who is receiving to Q2 are part of that one set. Is that what you are saying, Leo?
So let me put it this way. So anyone, so basically, let me put it in this way. Any like Bhavesh was saying, any producer send message, any consumer can consume message. But for this scope, we are not tracking consumers. So if anybody has read the message, it's kind of gone. We don't care, like different consumer groups are there.
Mm-hmm.
So we are saying like this will be a PubSub API, right?
Yeah, we just put a message, anybody can get it, and then we can have other things around that. But we are not making like Kafka, where we have consumer groups and then we assign offset to each individual thing. This is a really simple component. Does it make sense?
So you're saying only one consumer we are trying to implement in this, right? Is it?
So no, anybody can pick a message. Now it's a design decision on the implementer side, how they take it.
So what we are saying is that one message goes to, so suppose there are 10 consumers, one message goes to only any one of the consumer, not all.
Yeah, but if so there are two things when we say about consumers. Let's say this is consumer 1, and this is consumer 2. This is like let's say inventory, and this is like order, and then it could have multiple C1s.
Yes.
Right, and this could have multiple C2s, and then this is my queue. I can allow you to these two things, but I'm not tracking whom I have given the message. If this guy took the message 1, then this might not get the message 1. That's what I'm saying. So this would be like a design decision on the implementation side, whether they want to put C2 here or not, or they replicate like messages and then C2 would get from its own queue. But right now we are not tracking. So otherwise we will start building Kafka. That's what I'm saying.
Okay. So that's a good point. Let's say that one consumer and one receiver in that case, right? That is what we are saying.
Yeah, I made it simple. I don't track consumers. So, but I can give some other guarantees which people can use, but I am not tracking the consumers. That's what I'm trying to say.
And there can be multiple consumers basically.
Yeah, anybody can come and read the message. That's what I'm giving a guarantee. But I am not guaranteeing like who read the message.
Okay.
Yeah, and Asim, I think someone posted in the chat, like I think one of the guarantees is like if we have multiple consumers, that one message will be consumed only once. Do we want to offer that guarantee?
Yeah, so let's now I want to come to that. So that is actually a good question. So now there could be other traits of the queue. For example, how how many times a message could be read? Do we want to give this flexibility?
I think it depends on whether the consumer was able to successfully process or not. Right?
No, it depends. Okay. Okay, so then before that, let's see. Do we care consumer to acknowledge? So if the consumer acknowledge, so if consumer acknowledge, then definitely delete it. Otherwise, what to do? So there could be two things if consumer does not acknowledge. So then this guy this guy comes into picture. If I just made it one, so if it doesn't acknowledge, it's gone. So did you get my point?
Yeah, but I think they have to acknowledge, right?
No, it cannot acknowledge. You read the message and your consumer gone.
Then you keep the message and you deliver to the next one. Whoever
Okay,
acknowledge
so
it,
good
then you
question.
deliver.
But if I'm telling the message could be read once, then it can't happen. So that means I have to say something like a value from 0 to, let's say, 10.
And before, I don't know, like if we have like, I mean, like we want to make this as a configurable, right? Is that
Yeah, it would be configurable. I can put that. That's a good point. But I'm just trying to bring a point why we need this configuration.
I have another question. Like maybe we can just make this as three attempts, and if consumers can't process within 3 attempts, and we can move it to another queue like a DL queue or something.
Oh, so okay. Let me
Or
put
like
that's what you're trying saying,
yes,
Naga?
yes, and
Yeah.
I don't know. It could be n retries or n different consumers.
No,
to process
generally it's
this.
n retries. So after n retry, we move to another queue. Could be a dead letter.
And another thing is like when one consumer is
again, this is a configuration. If you don't want, we'll not give it to you. But yeah.
So if we are saying that retry, so does it mean that we are actually pushing the message? Consumer will not pull it?
Yeah, I mean, like he tries to pull the message. Like when he's pulling the message, they probably like don't delete at first because it will be invisible for other consumers. So so that's invisible is guaranteed with some certain timeout, and and after certain time it becomes visible, and again somebody tries and process again, they are not able to. So if they are able to successfully process, then I think consumer itself would delete it, or I don't know, like
yeah. So
internal workings. Yeah.
So we have mentioned if consumer acknowledge, then delete message.
So that means each message will have a what is that, lease, right, or something? Yeah.
So
because a consumer takes it and we have to give some time before it goes to someone else.
Yes, so good point. So that would be like an invisibility. So so again, it could be a configuration. So who is creating this queue can tell, like, make it invisible for 60 seconds. Or it could be, they can also decide on an exponential path. Or let's make it very simple, like they can define how much invisible. So it is again a configuration. It could be like, let's say 30 to n seconds.
Okay.
Or we can make it like 0 to n seconds.
Yeah. And another thing is, does the message have a lifetime, in a sense, if nobody consumes the message?
Oh yeah, that is a
What
good
happens?
point. Yeah.
Yeah, I think that's I mean, like a valid requirement. Otherwise, our queue will be infinite.
So we can say, like, I know SQS how it does. It could be like 0 to
14 days.
10 days, and for SQS it is 14 days.
So maximum, there would be some cap, right, on maximum how many days it will keep.
Yeah. It's a
14 days is a cap, I think, in SQS, but I don't know about other queues, because the longer you keep, I think the more data storage you want, so which will be hard to handle.
Let's make AWS happy. We'll use 14 days only.
And okay, so
Okay.
that so if you keep this 7 requirement, I don't know if you still want I think in the number 5 I mentioned queue size. I mean, like in the below, I think we need to re-number those.
Okay.
It will be number 9. So I think we also need to define a message size, like one message in a queue, what size it can be, like
maximum size. So that is a good point.
Like 512 KB or like 256 KB, or you want like more.
So we can say like how much, like 1 to n KB, and what could be the n, like you can make it like 100
or like I don't know, we can be really
like make 400, then DB sports skill 400.
Okay, yeah, I mean, like, because I think these calculations will be needed for determining how much size we need or data storage.
Okay, so next but in terms of audience and people, so are we clear the sequence?
So just one thing, I mean, we are considering at least once. Can we just maybe try to implement exactly once?
So I think that would be a design decision, how we implement this thing. So I don't want to bring that right now.
Are we basing this design specifically on SQS and SNS?
No, this is not. But okay, so I think the overall idea is like we know, at least I know about SQS. So SNS is not used anywhere here right now. But SQS is one thing which is on top of my mind. So definitely it is driving my thought process.
Okay.
I think if you guys have other, I mean, like some other options that you see in other queues, you can bring that up too, and we can decide whether we want to support, like what it would take to implement those capabilities.
So one question is like priority of the message is out of scope for this.
Okay, so we haven't reached here. Let's first reach here and then check. But are we good with this thing? So consumer, if doesn't delete, then there would be a definition like how many times it could be read. Otherwise, and after every read, we'll make it invisible for a few seconds. And after n retries, we'll either put it to dead letter or it's gone. Again, it's a configuration if you want to dead letter. And
what does invisible mean?
So basically, basically consumer read the message from the queue and will make it invisible for like 30 seconds. So if this guy has 2 instances, then other one should not pick that message for another 30 seconds.
Can you tell me, like, I am not able to understand what is the use of it. Can you just give me a brief idea? Why would we want to make it invisible?
So otherwise, okay, Naga, you want to take a shot?
I mean, like if you take 2 different consumers, it will make better sense. I think, for example, so if one consumer is processing, let's say, if this is a bank transaction, or like you can take any transaction, but like if one of them is picking up and processing, And until it's successfully processed, we normally don't delete the message from the message queue. So I mean, like, we don't want, like, what if we in the middle of the processing we fail and we already deleted the message from the message queue. So then, like, if we are not able to successfully process, then I mean, like, it's something that we already took. And if our process fails for some unknown reason, then the durability is lost. We have lost that message. So it can be a transaction, so which is key to the business. So I mean, like, for those reasons, normally whenever the consumer tries to pull the message from message queue, it is not actually deleted as they pull the message. So it will be kept invisible until he confirms that this is successfully processed and we can delete it. And for that period of time, which is like invisible or like message visibility time, so let's take it 30 seconds. So whenever other consumer tries to see, those are invisible, he pulls the next message, which is after this. So I don't know if I
Got it. Basically, we want to make sure that until the processing happens, nobody else should pick up. And the requirement is that one message is picked up by one and only one consumer. Is that correct?
Yes.
Okay. Thank you.
Let's say
Yeah, at a time, one consumer can have that message basically.
Yeah, it's at a time. Yes. Yeah. Thanks for that.
Got it. Thank you.
with this number. So let's say if you think you could not process that message in 30 seconds, then we need to either notify back to the queue. So there are ways a consumer can again tell queue, hey, make this 30 to 60 now. But let's not go into that for now. Let's say we know like within 30 seconds, we will able to consume the message. So what I'm saying, like this guy is still working on the message, 30 seconds gone. This message will become visible and this will be picked by the other consumer.
Okay. Yeah.
But this only happens if we have this settings. So if I tell like I can read multiple times. So if I say I can only read once, then this setting does not need.
Correct. Yeah, that's why I was clarifying the requirement. Yes. If multiple consumers can have the same message, then this invisibility doesn't come into picture. Got it.
No, if the read is only one. If there's, so we tell like we can only read the message once. So that means when it is read, it is gone.
Okay.
For clarification, I think there also where suppose there are one producer and multiple consumer, right? PubSub also. In normal practical system, we would have this locking mechanism where, from that multiple consumer, there will not be, when you say multiple consumer, it's not like a one consumer for each, there will be an end consumer for multiple receiver, right? So in that, within that receiver, one only message is read by only one at a time. And if it is not processed by that consumer, it is, come back again in the queue so that somebody else can process. But I think we are keeping our discussion to only have a one publisher, one subscriber, right?
We are not tracking the consumer.
Yeah. No, thanks for so I was asking because I have used Azure Event Hubs. So in that, we don't have this requirement that one message should be given only to one consumer. Like the same message has to be given to all the consumers. That is the requirement there. So because of the requirement, I was just trying to clarify the difference.
So that is available in any queue as well. Let's say as a service bus also it is available, but we are not doing this right now basically. We are saying that one publisher and one consumer.
Got it. Okay. Thank you.
Okay. Coming to the order. So do we need order?
It's order of what? The way message should consume?
Yeah, message ordering. I mean, so let's not support this right now because again, it will be.
Yeah. Also, I'm not sure. It is practically a little bit. Yeah. So does other queue support the ordering? Because I know service bus doesn't.
Yeah, SQS has this FIFO queues, but its scalability is limited compared to this normal queue.
Because then you can't make it distributed, you can't make it eventual, because otherwise now you have to sync everything before giving to the consumer.
Okay.
Okay, queue size. I think we should have a cap on the queue size.
So queue size means, so we have a
Like
cap on
1
message,
million
right?
messages, or I think we have a cap on message size and lifetime of the message. Like we can use those two to support as much as possible. But like if you still want to define in on top of that,
I think I like this idea. The reason is that, see, the message size is 4K, right? Can I make 1 billion message, or can I send 1 million message, or can I just say, 1,000 message?
Yeah, so, I think its queue capacity is generally limited. I think it's not as I don't know if it can support like more than billion or something.
Yeah, so we'll cap it to some number, right?
1 million or something. Do you want to?
The size should be in memory or numbers?
Number of messages. It's queue size, right? It's number of messages.
Okay, so I made 1 million, and what else? Do we want rate limiting?
What is it?
Limiting? For producer messages. It's like somebody else said, right? If you have a cap on the payload size, and if you have a cap on how many days you want to store messages, if you exceed that cap, the oldest messages are just going to get deleted. How can you have a limitation saying you can only have 1 million messages? Then that sort of goes against the point of having a queue where you only do it because you want to decouple systems.
But if you don't do that size, then there might be a case that out of 10 queue, due to one queue, our whole RabbitMQ infrastructure can go down, right? So take the example that one of the application is producing lots of messages compared to others, and there is no consumer for that. So it will consume all the whatever the available memory we have, right?
Right. And then if you keep sending more, aren't the oldest messages just going to get dropped?
So I think normally message will not get auto deleted unless it's timeout. Let's say it is valid for, let's say, 14 days. After that only it will go off. Now, if your queue is full, the sender will get error saying that you can't send anymore because your queue is full.
That's basically throttling.
Throttling is different, right? So we say that you can send 1 million message, but you can't send 1 million message in 1 second. Let's say my throttling policy is that you can send 1 million message, but it should be distributed between, let's say, 10 hours, or within a day you can send 1 million message. That is throttling, right?
There's throttling, right? That's throttling in the terms of like quantity, and then there's rate limit is what it's.
Okay, yeah. So here basically we say that each queue have a finite size. I mean, I like the size instead of number of message because, if we go into the design, it is ultimately we are talking about the cost of storing it, right? And we are saying that if somebody has a 1 kilobyte message, we are allowing him 1 million into 1 kilobyte. But if somebody have a 4 kilobyte message, still we are allowing same. I was thinking different way where, if I have a 1 kilobyte message, I can send 4 times than the 4 kilobyte message.
Yeah, just to refresh, I think one of them, Naresh posted a message on how the SQS supports unlimited number of messages, but like if you take at a time, it's supporting only like 120 in-flight messages.
Yeah,
standard.
So this number, okay, that's good. So then this is basically in-flight messages. We are telling that 1 million can be in-flight. Yes, that makes sense.
But even that is on the higher side.
Yeah, I think 1 million is higher. Yeah,
1 million is extremely higher, and also if you look at the size consideration on your 0.9, 400 KB, if you multiply 100 into 400 KB, and then you kind of derive the size in GB, you are talking about 30-40 GB. That could be on the higher side.
So 1 million. So I don't have experience about STS, but Azure Service Bus can easily support more than that, by the way. So if I have a
the
premium
in-flight, I think there is a difference between in-flight and the in-flight. I believe. I mean, let me ask you this: the queue size. Are we talking about the in-flight queue size, or what is it?
Actually, originally we wanted to consider if we want to keep a limit on queue size, but that is something we can still keep irrespective of SQS. But like if we want to support unlimited, then we have to keep a limit at a time. How many messages can be there in the queue? So which is what I think is in-flight is, unless someone else has another understanding.
So in flight means we're talking about like how many messages to keep in memory, and as we grow, we just back it up with that.
Correct.
Yes,
that's my understanding. Correct.
So in-flight is just in-memory cache?
No, it's like I think these are the messages you can consume instantly. Other messages would come eventually.
Oh, is it? Okay, I think this is something new. I don't know.
If you're going to see how many messages I can consume immediately, it will show 120. And once you are done, then only it will bring other messages in. So I think that's my guess. What they would be doing, like they might have a hot and cold storage, and they might be taking unlimited messages, putting in some low cheap like S3, but the messages which are hot are 120. And once they are gone, then they bring other messages in.
So there is no limit that how many messages I can store?
Unlimited.
Then it is easy to DDoS the service, right? I can write a rogue service and that just keep writing the message and doing nothing.
Okay.
Right? I can have a 1000 node that just keep writing the message. All are 4 KB within the limit, whatever it.
They will charge you. That's
for the queue, right?
Queues does not come free.
I think just to clarify, I think again someone posted, I think it's Naresh, I also read that in-flight messages are the ones which are read by the consumers but not yet deleted. So I think this is a number which represents how many messages are currently being processed.
Oh yeah.
So I think the way we put here is like incorrect.
Yes.
But,
yes. Okay, let's make
we can remove that. We can remove the in-flight message restriction for now. So,
and even we can have for now have some queue size to make it simple. Then
okay.
Let's take some reasonable number, and I think let's proceed. We are almost like 45 minutes in requirements.
Yeah, I think we need to head to at least high-level design.
And rate limit. Okay, and I think I have just batch read. Okay. So batch read is like one consumer can give me 10 messages at a time.
Yeah, for now, maybe we can just make it not, and we can take it when.
So let's make it what is our V1?
Optional.
We can make it V2. V2. Queue size we can right now take as V1, and then in V2 we can make it unlimited. V1 and V2 make it order. And I think rest everything is what else we need. V1 and rate lifetime also. Let's say V1. Tag letter, I think we can make it V2 for now. V1, V1, I think, and yeah. Okay, so any conflict in this?
One thing is after
could you
after the lifetime of the message, right? Writing that to a persistent storage of ones that are not consumed. After 14 days, we can add a case and put that to V2. Storing that to a cheap device or something, right?
No, it will just delete that message. Think like after 14 days, it is gone. So I'm not making as a configuration now. after 14 days, that message is deleted.
Okay, so we don't need to track like what didn't get consumed or anything like that.
It is there for 14 days. It's auto-deleted.
Basically, once we have a number 6 in place, the number 7 can utilize number 6 and send those messages also in, let's say, dead letter or things like that.
No, we are not doing that letter. So that's what I'm saying.
Yeah. So I'm saying that in V1 we deleting it.
Yeah.
But once we have a number 6, those messages can go, rather than delete it, can go and sit into the dead letter queue.
Yeah, we can on that, but right now we are just we are only high level. We are taking this. If consumer acknowledge, then delete it. Doesn't acknowledge, then give options to reread based on the config and make it invisible. And after 14 days, delete it. I think these are our main thing.
Yeah.
And out of order we are taking for simplicity. And this is also we are not going to implement, but we will consider as part of our design. That's it.
And do we need to track how many messages we deleted?
No, right now
we can add that as a V2 or something for
we are
tracking.
not like okay, let me put it.
Monitoring or something, right?
Yeah, monitoring again V2.
Yeah.
Okay, do we want to do some kind of non-functional or estimates or jump to high level?
I think we should quickly add some NFRs too.
Okay.
Right. What is the scalability? How much geographical availability? And what is the performance metrics?
So scalability in terms of message size, right? Like in that case, we still want to go for unlimited, or because scalability is like as the number of messages increases, right?
I mean, yeah, high throughput. It's in simple terms.
Yeah.
So in case of RabbitMQ node goes down and we restarted that, so for that purpose, do we want to write the messages to the persistent store, maybe in the file or somewhere, so that when it will come up, we will not lose any message?
Yeah, durability is that.
That is durability.
Yeah.
That we have to be in the durability.
That's a must. Durability is a must. Scalability can.
We provide. You can put messages, but up to 100,000 K. And performance should be, I think, for performance read as quick as possible.
Yeah. Low latency.
So, or there is a latency, but maybe let's say finite number of latency, right? So single digit, double digit latency.
Mm-hmm.
That's what we are saying in performance, right?
Yes, that should be.
So read as quick as possible. The same read. What that?
Basically, as you put the message, it should be available as soon as possible.
Oh, okay. I see. Yeah, same thing. Okay. So it is the latency between producer produce it and consumers can see it.
Yeah, or pick it. So basically, we want as quick as possible. Like as you put a message, it should be available to consume, and the other guy should be available to read it.
Mm-hmm. Okay.
Okay, durability, we know. I think this would be because we have out of order. I can make it highly available, and eventual consistent.
What is eventual consistency in this case?
So basically, our requirement is out of order. So you put 3 messages, and you read a third first, and you read first after that. It is like,
I see.
Basically, we are not giving you order. We are giving you out of order. Basically, we are claiming we'll not give you in order, but that does not mean like we'll give so bad. So basically, the guarantee is not there for in order.
Okay. It's still not clear to me that, I mean, here, if we say that, I mean, we will push to the consumer.
Message 3 message in the queue. So
okay.
And then so I gave you third message first, and then I gave you first and second. So basically, first message came 1, 2, 3, but how you read it, third, first, and second. So that means somewhere the first message came after third.
And why do you think that? I mean, we will deliver it that the third?
Because
No.
we're not supporting order.
It is not
No,
that sorry, go ahead.
But the system already have these 3 messages, right?
System does that system we are giving system a flexibility to choose this. That's what we are telling.
Basically, I think what Azim want to say is that if n message goes in, n messages will come out, but we don't know the order.
We don't know the order. That will help us to design a system. If you tell me right away, hey Asim, I want this thing, then my design will be totally different. So there will be 2 different design I can do based on just this requirement.
So this ties to the at least once delivery, right? Or did we remove that requirement?
No, at least once would be there always.
At least one would be always there.
In both cases, it would be there.
Yeah, both cases, I will give you a message once, but I don't know when I'll give you that. So that is my eventual kind of system.
Is that difficult to maintain the order? Can we maintain the order? It seems like a logical you do it, right?
So that's what we are telling. Like if we have to maintain the order, then it would become a different design if I have to think.
A lot different, or
yes, a lot different. So we have to go with either one thing. I can't go with 2 things. So we have to decide now. My preference is to make it simple. Let's go out of order.
So basically, if you want a first in, first out kind of a queue, the design can be a little bit more complicated. I think with people thinking like, oh, it's obvious that if someone comes in first, why is one not going out first? It's because if we had a single machine and all, that would probably be easy to handle. But when you design a high scale system, you will have multiple front ends, and there will be different multiple back ends, and the multiple business and middle point. So there can be race conditions and a lot of different cases where this order might go. Like for close range, it might not be in order, and to preserve that order, you might end up like losing on performance, and basically design has to change because of that. And that's why I think what right now Asim is always talking, saying like, I don't want to take that complexity around right now. I just want to make sure that I'm fast and I'm able to send things through. And maybe as a V2, we can think about ordering where we can adjust that. A second problem.
Yeah. So yeah, basically what
I'm
happens is
thinking
as
that
a consumer,
the
right?
difficulty is at the system, at the system design. It's not from the customer point of view.
So Leon, there is another thing also. Okay. I mean, practical system also, if you are doing FIFO, they don't give the same scalability. Right. But that doesn't mean that queue doesn't support that. Some queue support saying that if you want FIFO, I can do that, but then your queue won't be as performant as without FIFO.
And it will be costly also.
Because there I can't, if I have a fat backend and everything else, I have to make sure that only one person is delivering, reading and delivering this message to the consumer. So I can't take advantage of all the scalability and everything else. So the same queue that supports FIFO and non-FIFO, they have a different number, scalability number. So is that make sense?
Yeah.
Okay. So we are saying that this both are basically, the point is that both is possible, both can be done, and as you are saying, it is the implementer's responsibility to give that, but both are different system design.
So there are 2 aspects to it. One is whether the queue, how the messages get into the queue, whether it's ordered or not, right? And second thing is how it's getting consumed and written into the backend is the second way, right? So what is the question here? Like queue will be ordered, how it gets into the system, you don't. What is the
So
question
in this
here?
case, I mean, order doesn't matter, and output also doesn't matter. But the end message coming in will end message will come out.
Yeah.
Yeah. So basically in real-time systems, right, what happens is the irrespective of how the queue gets in, the consumer application, right, it may have a microservice which actually consumes all the queue messages, right? Even though second microservice like instances, right, you have 5-6 instances of running. So which one picks which and how it gets written into the database is completely independent. So we can't order the guarantee of how it gets written into the backend, but it will guarantee that the events will be picked from the queue and it will be written. But you can't guarantee that. But but if you want to add that to the mix, then I think the design will definitely change.
Yeah. I mean, in that case, receiving design also will change a little bit because we have to record and guarantee the order there, and consumer also will change it because we have to deliver in it, and both will be different.
For simplicity, right, we can say unordered message will be consumed. That is our requirement, right? So message will be consumed. But in V2, if requirements change or you have some specific application where the ordering is important, then you may have to have special logic at the receiver and have some sequence numbers and process it in the same way.
Yeah. Or assume you want to call it eventual consistency, eventual delivery. I don't know. Okay, because people have a different meaning of eventual consistency.
I can tell you when we design it will become eventual consistency.
Yeah. Okay.
Yeah, I think since we already called out in the other requirements, we can remove it here. I think that's what I feel in NFS.
Okay.
You can have it highly available though. Yeah, that's
availability we need, right? I mean, 4939, whatever we want to support.
Yeah. So yeah, we want to head to high-level design unless someone else have a question.
Okay, I think we can jump and circle back here if we need. How it sounds.
I'm not sure whether that's more of implementation details, like we want to use pull based mechanism or push based. Where should that part come in?
Let's have pull based only.
That's a design, high-level design. We can discuss that.
Yeah.
Oh, what?
Control Z.
Okay. I don't know where that guy gone. Okay. So we can always bring it here. Okay. So, oops. Okay. Okay. People can even access this link, right? And anybody wants to draw, just please feel free. So I could start, and then anybody wants to chime in, please. So what we have seen right now, the things which are coming to my mind is there should be some kind of write service, and then be something like admin service. So where the producers can create queues, something like that, and also get some queue information back, and then they can submit message to the queue, and then there should be consumers who would be kind of reading the message, but they should know the queue name. And yeah, so that's all. And then behind the scenes we'll do some magic how we want to store it. Where this guy will write to some store, and then we should give some flexibility to read it, and then now we can start thinking more about this. Looks like a very tiny miny high level diagram, but now I can go deep into that. Thoughts till now?
Yeah, I think this looks fine to me. Basically, producer and a consumer, and then in between there is a basically queue and other services, right? That's what admin services.
Yeah, admin services is creating queues for you. Like you say, oh, I want to create a queue. It will say, okay, I'll create some queue for you, give you a queue ID. Using queue ID, you can send messages to the service. Service will now persist it somewhere. And then when the read will say, I'll say, oh, I want to read messages for this queue. Then we can even tell one message at a time. I think we decided on one message and it will start giving one message at a time. And then all the requirements will have to deal here, how we tackle reading the messages, storing the messages, distributing the messages. Yeah. And yeah, so this could be, again, could be different instances which is supporting this entire stuff.
So how does...
Do you want to also add an authentication or a REST call or something?
Oh, so
just so for admin, and when you want to log in and create you want to create one service, just mention it. And when you're actually sending the message, you'll have another same service, but with different credentials. So when you want to create a new queue, and if you are authenticated admin role, then you'll actually create it. If you're just like a publisher for that, then you'll only able to sub-publish the queues.
So I can bring that in, but that is not a core requirement. So I would like to avoid till this point, and if I have time, I can bring it. But otherwise, we'll get deviated totally from like.
Yeah. So we can mention that in interview that there will be authentication. Then after that, we'll do this.
Yeah.
So that we know that is the case. Yeah.
So for the consumer, this seems to be a pull request. But how does the consumer know there is a message for me to consume?
So
is that going the way it is that periodically it's gonna go to the database and query that?
So I'm doing the pull request.
So I think the good thing is, I think what Leon bring up the point is that we never discuss saying that it's a push-pull model or what model, and most of the time it is a push-pull model, right?
Yeah, but
pull model.
In this high level, model. I'm proposing a pull model.
Yeah, okay.
So you're when you say you are the consumer, right, Asim?
Yeah, I'm a consumer, and the person who is proposing a design, but that's what we are doing. Like everybody then can say, oh, why you want pull model? Why can't you do push model?
Yeah, there are drawbacks of both pull
message.
and push.
I keep query that, and then there's no message for me. Then why I have to waste, keep polling it?
So
yeah, this is one point. When you say pull model, sometimes you may have you'll be just querying every minute or 5 minutes to see if some message is there. If it's there, you'll process. Otherwise, you'll it's like a sprint scheduler, right? If not, what you will do is you will actually get notified once the message is in the queue. That's a push model. So ideally, most of the people generally use pull model depending on the requirements, right? So because we can set it up in the requirements itself based on the
become totally different component of notification service.
Yeah. So Leon, to answer your question quickly, practically, there will be something called as a long polling that will be used to overcome this concern that you raised, saying that why I have to keep polling if there's no message. But maybe
and then sorry. And then I always have to create at least
I
one
think there is
long
a confusion here that the long polling and all. If this client is not actually a web client, that you are making a request through there. So it's just actually the client which send a request to this guy, the middle guy, that I'm ready to get the new message.
So is this a blocking call or a non-blocking? Are we saying the pull?
So okay, so there's no blocking, non-blocking call. My assumption is that there is a dedicated connection between these two, and as soon as this guy is ready, either it could be blocking. Let me rephrase that. So I was thinking that will be a dedicated connection, persisted connection.
So I think then we are talking about different thing. Then we can do the push as well.
No, I think let's do pull with long polling now.
So pull with long polling is a thing for this kind of system. But I think we keep out of this discussion. Let's say that client is polling basically.
Yeah, one drawback of pull which might not make it work is if the consumer is not ready to consume those messages, but the push would keep pushing them, right? So it depends on consumer capability of processing, how fast they can process.
Yeah, I think then we'll pick up same thing. This guy is telling, "Oh, take more," and consumer telling, "I can't take more."
Yeah, I think we can decide on pull model with the poll of every 5 minutes. For at least we can, in the interest
either
of time,
periodic
we
polling
can
or long
periodic
polling, both of
we can say periodic polling, and then later on, if we have time, we can actually do different approaches.
So what is the difference with periodic and long polling?
I think long polling is efficient in the sense, server will be aware of the client connection and send
So long polling is that the client make a request, and until server has something, it will keep the connection open.
Yes.
Client will hold. And the periodic polling is that client make a request. If server has nothing, it will reply that I don't have anything. The client will continuously repeating it again.
Yes.
After certain period of time.
Long polling, I also think it's not infinite. It's like you can tell 24 hours, and then you have to reconnect with
that you can configure.
It's still efficient, right? You don't need to make so many calls within those time. And once server responds with something, again you open another long polling request immediately.
Yeah, but
so that
in the long run, you will always waste one connection, right? Versus the periodic one, you open, you close. You don't, you free.
Yeah, all these long polling and periodic was way before when WebSocket and kind of thing was not there, unless you go and use the raw socket. If you have the raw socket, why do you want to open the connection again?
Yeah, it makes sense. So I think it depends on where your client resides. So
exactly. If your client is on, if you are talking in terms of the long polling, so we are thinking that our client will be communicate with this component through the REST-based API.
We are assuming a distributed, yes.
Yeah, but most of the time when within the service, so it's not most of the time it's not REST-based, it's actually RPC-based, using all these encoded protobuf or some kind of thing to reduce the payload.
So what you're suggesting, could you repeat? I couldn't get, Praveen.
What I'm saying that, depends on where is your client. Your client is actually, whether your client can make a RPC-based call or not.
Okay, if we can make RPC calls, then how things
will... one is that you can open a persistent connection, a raw socket, a plain TCP connection, and then you can use your own protocol or the message format and communicate through that. You don't need to open the connection again and close it again, open it again, because when you open the connection, so there are some handshaking in between, right? So why do you want to do that again and again?
That's a wonderful point. I think I also agree with this.
It depends, because sometimes, if you keep one connection open, you have to waste one thread, right?
No, you don't need to waste the thread. You can keep that connection. When there is a socket, it does not mean that you have to start a thread for that connection.
Yeah, so basically, you know, we can use system which is basically IO efficient, like Nginx or something like that, which basically use event loop to process such stuff.
So they usually like the RPCs and things like that, right? You use in your backend systems, right? But the front end talking to the client, you generally always you would use a port 80, which is HTTP connection, right? And that's why and is like long polling is kind of giving you long connection without opening connection again and again, and still providing you kind of that asynchronous semantics. If you like in the front end side, if you use like raw sockets and different ports, the problem is like in the internet, right? So that there are anything outside of port 80, typically things are blocked, port 80 443. So you could you will have problems of this connection. So that's why like port 80 or 443 are the ones you generally get through, and you use that connection, and then you basically do long polling where you have the connection open, and as someone explained, right? So you make a request and server keeps it open, and if there is something there to be delivered, it will respond that time, and client request again. So you're still keeping the connection open like a raw socket, but you get the response only when something's available.
I understand, but this particular system is designing for internal services, and we are. I'm assuming this system we're using in our internal services, not for open and
No.
So we didn't define that, right? That internal or external.
So
like
we are
the clients can be anywhere.
Yes. So I think yes. To make it to clarify, it is a service that maybe end up a customer will be using it. Okay.
Right.
It is outside. It's not something that internally we are building just for that. And in all that sense, I think this is very good point. The opening of the port, right? As time goes by, many people will like HTTP just because that the security that it provides. Other things may be faster, but you lose the security, and none of the system admin in a real world want to open any other port than the HTTPS. Not even HTTP, by the way.
Yeah.
No, I mean, in real world also we use RPC, if I'm not wrong. Like for example, from a mobile phone, I actually sometimes use RPC, not HTTP. It's not mandatory.
I'm saying that mobile phone is fine when you are writing a backend. Okay, so see, those ports are fine from the browser or end user consumer from side, right? If you are writing a backend, I am writing my backend services, and any security auditing person would not like me to open any port on my machine other than HTTPS.
I see what you're saying. I get it.
Yeah. So for all other things from browser, from consumer side, it is fine. The moment I am saying that, I am building ordering system, let's say Amazon ordering system, right? The backend that relies on, let's say, queue. That backend doesn't want to open any other port other than the HTTPS, even the, wherever it is communicating.
Okay.
So I think both points are very good. RPC also is very useful, but I think we have to still consider that HTTPS is the only available. So, that is also a lot of places it is used in a real world system.
Yeah, I think RPC is also used in distributed setting, but and not many people are aware of it. Like for the simplicity's sake, like we can go ahead with long polling, but it can also be accomplished with RPC.
Yeah.
Because
So pool and long polling, and okay, let's go with that. And pool and long polling is supported by HTTPS, right?
Yes. So
yes.
You can do HTTPS.
Okay. Just want to confirm. Thank you. Okay.
And any recommendation of whether if the same thing someone asks, say internal versus external. So for both, it should be HTTPS, or what is the recommendation?
Now, I think in that case, what Praveen was mentioning, that makes sense if you want internal and make it really more efficient,
Right.
Saying that, you can't, because
RPC
HTTPS
is typically for that. Yeah, RPC typically your internal
Mm.
systems, right? All these backend components when they communicate, right?
Each
So
other,
RPC
yeah,
is the
you
way
don't
to go.
want additional overhead of all this. Yeah.
I mean, so this will be useful only if you are designing a service that is consumed by internally only, and that also within your group or organization, right? For example,
Let's take yeah, I think the logging or monitoring systems is a good example in any big
Yeah,
companies.
I want to add one more point here that looks like there's a misconception here that RPC and HTTPS. So RPC is nothing. Even HTTPS REST-based call is you can say that it's an RPC call, right? So, but here you are actually taking your protocol is the JSON base. That's the only difference. Otherwise, the RPC is that you have to execute a function on the remote machine, which is happening in the case of the REST API.
Oh, sorry, I want to pause this discussion. Otherwise, we'll not able to complete our actual design.
Yep.
Thank you for your understanding cooperation. Okay. As a side note, I put like security encryption. Everything is a separate thing. If we have time, we can check on that. But where we were, okay. Pull and long polling is decided, done. Okay, I lost my train of thoughts.
What
Let's
about
start
like
with can you define the message attributes, key attributes that you want to use for different things? So
yeah. So basically now I want to discuss on like what would be our backend should look like. And here I was thinking in terms of something like NoSQL store to store my messages, something like that. And then I could have some tables like
why NoSQL?
I could SQL also, but I want to be really durable and distributed. A lot of messages are coming. So I want
my question is that why even database? Why not the WAL?
Why
or
not
append only file?
Why not?
Why not the append only log file?
Oh, okay. Append only log file. Yeah, I mean like when you say append only log file, just like
WAL.
that RDBMS uses.
Yeah.
So I mean like that's why I'm saying like I mean like just writing to the log is again good, but like you lose the
okay. So I want to log
functionalities of database, right?
So I want to make the message invisible. I want to retry. These are all the things which we want to track to have a retention policy of 14 days. So these all things will come handy if I use a database.
You can make it visible by moving to different log ahead file.
Okay, so if you want to do log head file, then I think Naga, you want to take a lead because I don't have any idea on that.
You mean I mean like we can abstract that with the RDBMS choice. I mean like it internally has the log for durability if you want. So I don't know, like otherwise, like if we want to explicitly have our own and have our own index files, which can identify different log entries, because even this log entries, like if we start using this log entries, so we still want to have, we need to keep rolling over, and what is the process for that?
How log entries?
And how do you
put one log, then you put another log, something like that?
Yes, so like we should probably define a size when we say append only log file, like we can call it like a segment or something, because that's where like some of this databases like which are mentioned in DDA book, like I forgot. So yeah.
So Asim, I would like to know your thought process behind that. You propose the NoSQL, and yet we have not agreed that what will be the payload for the message.
No, we have agreed the payload of the message.
Oh, we did? Sorry, I missed that then.
Can you actually define that queue?
Yeah, so I
what
want
the queue message will look like. I mean, like the message format.
So queue message is like we are taking a 400 KB payload. That's it.
Okay.
Payload.
Okay.
You can put
I mean,
anything.
like what I meant was like define something like message ID, or like is there any
Some kind of a database where when you create so I'm not pulling things out of this which we have abstracted earlier. So this is my queue table where you can create a queue, something like a queue ID, queue name, and something like a status on top of my head. And then there would be another table where you keep on sending messages based on your queue ID. Then
can you actually list those tables and like so that we don't lose track of it and we can refer it?
this is a queue table and this is message table. I only have two tables on top of my head.
Okay.
And then let's say this is message ID, and then this is queue ID from which queue it belongs, and then a created date. Then and then there are other things like how many retries are
Is
possible.
visible or not something.
Yeah. So you mentioned like Q1 order, and then retries are possible 3s. That's it, right? And here created date, invisible, and how many retries we are already done. It could be like, yeah. So that's what was top of my mind when I thought about a table approach. And then why I said NoSQL, this could be easily partitioned based on either message ID or queue ID.
So only thing the worry of using database is that considering we are planning to go with the high throughput system, and that's where I think NoSQL can become a bottleneck. That's what my thought process. I might be wrong.
And we can even do some kind of query based on the created date. Let's say I want to read next 10 messages. So I can go back and say on created date, give me all the top 10 messages or something like that.
I mean, in terms of writing, when you're writing in NoSQL, it is time consuming. So that's where latency can take a hit.
Yeah, NoSQL, I mean, like only why I don't want to go is like, I don't think it's strongly, I mean, like how the durability versus the RDBMS, I mean, like is guaranteed. It depends on the choice of NoSQL database. But with RDBMS, I think we have the durability guarantees, like strongly consistent one. And and like you can still index by created at to fetch the recent one, right?
But right now I don't want this thing. What I was trying to say, a strong consistency. I'm fine with the. But if you see, a lot of messages are coming, so I want something. It should be partitioned really well. That's what I'm trying to visualize. And then the read part should be fast. Does it? So that's what I was trying to think.
So you will partition based on what?
We'll partition based on something. I'm not telling what it could be, like a queue ID, or it could be a message ID.
We definitely need to do by queue ID so that we, I mean, like when consumers are pulling same messages from the same queue,
yes,
we always get the same thing. And another factor is, I think, the timestamp.
Traffic on the queue.
Or
also the traffic on the queue. Like if a queue is completely busy, then put it on the next partition of the queue, like the next queue.
Yeah, so we could have, if we are actually thinking about NoSQL, we can have something like a partition key and a kind of a, I think, sort key, which could define how your things would be assembled on the partition. I'm just giving my thought process.
Okay, let's write like partition key as a queue ID.
Okay.
And for now, and the sort key is typically
for here.
Timestamp should be right.
Timestamp of the creation. Yeah, basically.
You should be there.
And I think one way is, I mean, like when consumer is, I mean, like it depends on, I mean, like though the timestamp is much before, if the consumer has not processed for the last few hours, he still needs to, I don't know. We need to maintain the head, right? Like, how do we know this is the head of this queue? How do you?
No, so that
on what basis? Like,
the
is it based on the timestamp, earliest one?
couple of things. There is also something like a time to live, right?
Yeah.
I think we also need an offset because, like you said, how will we know what was the last process message?
So that is, we know, right? We have this retry count. So if your retry count is already 3, so that message should go away from the queue.
No, it's not about that. Like you have, let's say you received 100 messages, and out of those 100, how do you know which one you are giving first? Because you typically need to give the message which is older, or like which came first, or
So you can
not
use the
strict ordering.
timestamp, right?
Creating date will tell me, right?
Yeah, I think timestamp can be used. Because you are anyway sorting based on that. You can always try to get a message which is older. So yeah.
No, but here's the thing, like when it comes to reading one by one messages, I mean, how would we do that? That's something I'm still not clear with.
Okay, so on top of my head, what I was thought, this would be my QID. This would be my timestamp. This would be my message. This would be my retry. And then there will be time to live, which is 14 days. And if the retry already reached 3, that means I should ignore this row. And there should be another cleaning process which should kill this. So this is QID1, there's some message. And the timestamp is, like, say, T1, then T2, and T3. And right now, everything is retry 0.
No, that's fine. So how would you query? Let's say you have written the message. How would you query? Let's say there's one consumer trying to read. What query you would put on your database to read it?
I will try to query all the top messages based on the timestamp, the lowest timestamp which I see. So
And then
I will query anything which
But
has.
why do we want to check the timestamp? We already told that we are not preserving the order, right? So why does it matter?
Preserving the order, but we didn't.
Otherwise, some process. Yeah.
Like, think about, we are not guaranteeing the order, but that does not mean we'll not even try to give it an order. Then nobody will use our system. They'll say, like, I always get out of order messages.
So we can't have a system, let's say first in, last out anyway. So to be reasonably good, we want some ordering, right? We're not guaranteeing, but reasonably, basically we will try to deliver whatever
Right.
comes first.
So what I was thinking is whatever is on the top row, if it hasn't reached the time to live and if it hasn't reached the maximum number of retries, we can just give that instead of querying the timestamp, because anyway we are saying that we are not preserving order. Most likely what is there on the top row might have been the best timestamp because it's on the top row. Sometimes it might not be. So just give what is there on the top
How
row,
we
right?
are saying that it is a top row? Is it based on time?
Yeah, that is a question now. So I mean, like RDBMS can organize based on however it wants, right? Like yeah. So
I don't know about NoSQL.
I see.
Yeah.
Okay.
The NoSQL also, like, yeah, if you say sort keys timestamp, it is going to keep the recent ones upfront. I mean, like, depending on whether you did descending or ascending, I don't know.
Yeah.
It's still in. I mean, like, I think irrespective of that, it arranges all the next, I mean, like, the based on the time range, all like if you give a time range, it brings all of them, like it can try to pull from 1 or 2 segment for partition. So
yeah, I mean in NoSQL, within the partition, it will keep your data sorted based on your primary key.
Yes. Not the primary key here is like the QID plus timestamp.
Yeah, so in that case, the timestamp will be the second one where the data will be sorted based on.
So in this case, like the reason why we are not guaranteeing order, because it's already partitioned by QID, and it depends. Oh yeah, I think if you are reading for the same queue, we can still try to I mean, like, try the best order, because we already have sorted, so we can always give the one which is not read.
How are we assigning the QID?
QID is based on how the, like, let's say producer one created all the messages which are like order not fulfilled are going to be in this queue. We'll create one queue for this order not fulfilled queue messages, and whichever consumers are processing that order not fulfilled messages, like they can try to pull from the same queue. It's just you create an queue for the purpose, I mean, like, for the messages
I see, the
which you
based on
want
the
to.
message type of the message you're saying.
It depends on the business requirement, right? Like, let's say, yeah, it depends on your scenario. Like, for this type of messages, I'm going to create this queue, and if it's kind of one-to-one, like I want some set of consumers to process from this queue, and I can, like, on what their process, it depends on what consumer capability is. So if they're processing order not fulfilled ones, like, we can, all of those can consume from that queue.
There will be performance hit when we query data from the table, right? We have to sort or group them by queue, or kind of find them to see if we have exceed the retry. And one more question: if we deliver the message already successful deliver, are we gonna delete that row, or are we gonna mark it as it being delivered?
Yeah, so one of the, I think, couple of items that you bought, I think, which makes sense, like, once a consumer queries, like, or pulls, how do you, I mean, like, how does this pull work? Like, that is something that what do we do on that row at the time? So I think we typically want to update that row with invisible flag, yes, and there should be some tracking mechanism on that row, like which updates back to deleted or.
So a couple of other things which we need is like invisibility, make it invisible.
Yeah, so.
And
now that we are processing only one message, not batch, we know which message we are giving to the consumer, right? So that we can mark it as invisible.
Yeah, but you see, like, I don't want to mark it as invisible. I want to make it like dragged on, right? Last dragged on, because then somebody has to come and make it visible also. So I want that.
Oh, yes. I think you want to, yeah.
So I want, like, when.
I think the problem with last read on is, like, you can still have last read on, but if you have a simplified flag, I mean, like, you don't read that. So, or yeah.
No, but there's a logic, like, I don't remember whether we have finalized or what was the final thing. So invisibility is also what is that, a configuration, like 30 seconds. So basically based on the queue configuration.
Yes.
So we need to see, oh, this was last track within like 30 seconds. Okay, no.
Don't read that, yeah.
Don't read that, something like that.
Mm-hmm.
Yeah, I think last read on makes sense. Otherwise, we need to have defined another system that will take care of, that will become another problem.
Once system acknowledge, we can make a soft delete.
Yeah.
And later we can have something like a cleaning process, which can do some kind of a which looks for a couple of things: the retries and the soft delete, and then do the cleaning.
Yes, I think that makes sense. So
hey guys, if I understood right, if I have multiple consumers running and consuming at different levels, right? So one guy one guy may be at the end of the file, or one other guy may be he just started consuming.
No.
How does these consumption translate to a query? Because they could be at different levels, right? So maybe I'm missing something there.
We have decided there's no consumer group. We are not tracking who has consumed till where. If that was a part of a requirement.
Let's take, I think this scenario that we are trying to solve is like not like every consumer consumes all messages, but like any one consumer pulls a message, other consumers won't see that. So this may be kind of a jobs, like you have number of tasks in a system. Any consumer can pick the task and process it. So all consumers are doing the same function. So that's the idea here. I don't know if that is clear.
Okay, so you're saying that one message is for just one consumer? Is that the?
No.
Yeah, so.
Okay, go ahead, Naga.
I mean, like the idea is like there are multiple consumers, but all consumers are doing the same thing. Assume that they are doing the same thing. So any consumer can pick up the message which is and process it. And once they process it, there is no need for other consumers to process the same message. So it's deleted from the queue.
Okay. Got it.
So that's the one that we are solving now.
And we determine that based on the acknowledgement, right?
Yes, so there is an acknowledgement scenario also where let's go back. I want that as a separate component. Please, if you don't agree.
So if you are using long polling, like once I mean, like
long polling doesn't mean like it's successfully consumed. So I can read a message, but the message is bad. So I can say I don't care about that message, and then I don't acknowledge it also. But once I acknowledge, then I need to do some magic.
Basically, we rely on positive acknowledgement from the consumer saying that I'm done with that message.
Yes. Okay.
And time to the next consumer.
So okay. So not sure whether it's too early to ask this question or not. So what I'm thinking here, let's say there are two consumers and we delivered a message to one consumer and mark that message invisible, right?
Not invisible, but let's say that we set up a date saying that okay, this time.
Whatever, so that we can make sure that we already hand over this message to someone and we should not give it to another consumer.
Correct.
Until we get. And now let's say we do have some timeout here, and by that time we don't get the acknowledgement, right? And we now we actually reprocess that message and give it to another consumer.
Yeah.
And now the previous consumer one was slow and it processed the message and acknowledged it.
Okay.
So are we okay with that?
Yeah.
If two consumers process the same message?
Yeah, I mean, see, in a distributed system, the consumer knows that the message can come multiple times, and this is exactly the reason why it will come multiple times.
I think there should be a mechanism how they identify like this is already processed. So
no.
Otherwise,
I think too complicated. The system has to be kind of they have to think in terms of idempotent. Like if you do multiple times also.
Yes. Yeah, that's my idea. Like it should be idempotent. Like you should not change.
Yeah, so that is the whole idea. Like it's very difficult for otherwise the queue to find out what is going on. It's like I'm a candy man. I gave a candy to Naga. Naga didn't tell me I got a candy. Then you also asked Praveen, I gave you a candy. And then Naga told me I got a candy. Now I tell, oh, give my candy back. So.
So I think I mean it is reasonable to assume that because the timeout is decided by the consumer and the consumer, right? Saying that or when we define a queue saying that this queue this is the timeout, right? Or whatever lease. So consumer, if they want more time, they can ask saying that, give me some more time. But if they don't come back at all, then we'll try to give it to, someone else.
Yeah, I think that's what even I was pointing out. So let's say this component does a couple of things: acknowledge, get more time. So even this guy can say, "Give me more time." So what we'll do, we'll change few things here then on the last thread and increase it and make it current then.
Yeah.
Something like that. So if you can say like, oh, in one of my previous project, we have done something similar. So if the consumer thinks
generally, like if the consumer is not responsive, we don't know that, right? Like in those cases. So
no, giving a flexibility to consumer that
okay,
if consumer
yeah,
that
sure.
I need more time, 30 seconds is not enough for me, then it can go and tell back, like make the last track on current, like I'm still doing this message, I'm still working on this message.
Some sort of acknowledgement that I'm still working. Yeah, yes, you already
I'm
said.
still working. Don't give it to anybody else. So we are giving extra feature, but I don't think so. We should think it's an item-potent system, and a number of messages can read.
Yeah, I think the problem with that approach is like we should again limit how many number of times a consumer can do that.
Yeah,
otherwise, like it will
I like that.
become
I like that idea. I mean, that makes the system heterogeneous. I mean, some client may be very powerful, and some clients are has very slow machine, and maybe network is very slow. So with that idea, I mean, we can consume any type of client.
I was wondering if keeping track of this status is complicated. Why can't you have multiple partitions in the queue, and each partition is dedicatedly consumed by one consumer? In that case, right, you don't need to keep track of or share the status between consumers.
No, I think, but it has its own problems, right? Like if you, the moment you start, I mean, like, I mean, like we don't want to do that, because if one consumer is doing processing very fast, he may be consuming more messages than the, I mean, like if you have, how do you divide in that case? So I think
Yeah, it depends on
own...
how the individual consumers are consuming the messages. It's up to the consumer. As a queue, you are making the partitions distributed properly, and as a consumer, I think you have the responsibility of consuming it. And anyway, you have TTL in place. This is how Kafka typically works, right? So you have multiple partitions.
No, we are not doing Kafka-like approach. I think.
Yeah.
It's,
So one scenario I can think about that the design what we are thinking, that think like these Uber or Lyft, where the drivers are connected and they are waiting. They are some sort of a consumer and they are waiting for the ride. So we can hand over the ride to anyone. That makes sense.
Maybe I'm not able to understand the difference. How is it different from this?
So here in this our system, we are saying that any consumer can consume the message. Whoever is available, we will hand over the message to that consumer who will demand first.
Okay.
And what you are proposing, you're saying that we can partition and just dedicate one consumer to one partition.
That's right. Yeah.
Okay, I think again I need to consideration of time. I need to pause the conversation so we can wrap up this thing by 11.
okay. I mean, like that's a good. I mean, like
if people want to stay, we can chat more. But I want to wrap this by in another 10-15 minutes. That's what my goal.
Yeah, I mean, like whatever you said, like it's a good, again, trade-off, like why you want to do that. So you need to really convince, like if you are in an interview. So whatever the decision that we make. So I think the reason we already mentioned, right? Like why we are doing this way. So let's proceed, Asit.
Okay, so a couple of things here. What I was thinking on top of my mind, I was thinking about this as a no sequence store where I can partition thing. We'll have single leader, and then there would be a lot of followers, and they could be as a read replicas, and all the writes would happen on this. And now we can see what could be the issue with this. Does it make sense? It sounds good.
Okay. So the single, I mean, like we are now dependent on like how much we can write on the single leader.
Yeah, it could be. So now there would be trade-offs between single leader or multi-leader or no leader thing.
So are we saying this is like a single leader per queue?
No, this would be not per
Whole
queue.
system has one leader.
Yeah, we can have.
No, we are discussing about database, how it's internally handling, like whether it's a single leader server or like.
You remember we have a kind of out of order constraint and other things. Why it is coming into picture? That's what I was trying to highlight. It could happen like the reads are happening on this guy. All the writes are happening here, but when you are reading from here, and then you will miss a message initially. Does it make sense? Okay, no, I think I made it complicated.
Yeah, so could you actually highlight that? I mean, at what point you will determine as now this is leader based, right? So which means that the particular leader will serve some set of queues only. So at what point you will determine that you have to go to this queue?
We can even make in that way then, like there could be multiple single leaders, and then we can have something like this. Does it sounds good then?
You mean range based?
Yeah, range based leaders. Then like it will become then a kind of consistent hashing.
So then how will you handle the hot partition here?
When you say hot partition, that means
so now as you said that say like
queue
A
is too
to
much
Z.
overloaded. Yeah, kind of if your range is on the queue names or queue IDs, if you are partitioning on, I mean like the servers based on that, then like yeah, the hot partition is like one queue become too much overloaded, like how we handle.
But again, we are distributing data internally. That's what I was thinking. So I was telling at high level, this would be taking one set of queues, and then we can say like how we can do it internally. But that's what I was thinking.
So yeah, I mean like I think irrespective of whether we again like partition by queue names, like first level of partitioning you are doing by queue names, like but even for a single queue, I think whatever the other person said, I think it makes sense because we I don't know if
our whole design was based on QID. So that
yeah,
means we are wrong at the first place then.
No. I think the partitioning, I think though we do strictly based on QID, I think even a single queue can become overhead. So how do you again, like, I think we need some additional thing on top of the QID to partition. So the partition key itself need to be, I don't know if we need to combine like for hot partitions, like on top of QID, do we want to add something else?
But how will know it is a hot?
The producer is dumping so many messages on that specific queue.
But we have a limit of 1000K messages.
Okay, I mean like yeah, in this first version we have, right? So I think then we are good. So if we want to go with unlimited, we can't do that. So we will end up I mean, like we need to scale further.
Retention policy, retry policy, and then number of messages. So I'm just trying to see how the partition will become hot.
I think for this case, like since we are supporting like 100K messages, I think we may be able to handle within a single partition. So, but like if you say unlimited messages, then I think we definitely even a single queue ID need to be on multiple partitions.
Okay.
So we need to add some other factor to partition.
But what would be the alternate? Anybody wants to propose an alternate or something else they have on their mind?
I mean, that will work. I mean, that HDF has actually used the leader base. It's a NoSQL leader base. It used this range-based partitioning. So what they do, what they do actually, the leader check that if it's actually the size or the number of record goes beyond some threshold, then it actually create a new partition. So it's actually follow the dynamic partitioning scheme. So it creates the new partition and it split the load.
Which I didn't get like where it is being used.
HDFS.
HDFS. Okay.
I think it internally still goes on segment by segment, so it still uses the time in addition to whatever the. So I think we still want to for those hot partitions, like or like when we go for unlimited, I think the partition also needs to be done in addition to the QID, and also we can use a timestamp there as well, because we don't use a full timestamp, but like if you take like for in a day, like per second, if you are getting so many messages, we can take say 1 minute partitions, or like you want to, I don't know, it depends on how many messages comes in certain time frame, but like you can define that time frame, all the messages in this time frame fall in this partition. So but like you need to keep rolling over the partitions, so as and when the time beyond 14 days gets over.
Oh, but I still, okay, let's say we are going with this for now. We have a very simple use case, but there could be one more issue I see. Let's say we are making all writes here, right? And we also told updated that last read on here, but the follower didn't get that, and we read from that. There could be possibility that the message can be read more times, although it's supposed to be invisible. So I'm just trying to highlight that.
Could you repeat again?
So basically, we read the message and we told like the last. Okay, so we updated the last read on, right?
Okay.
And it is not, it has to be replicate on its followers, right?
Mm-hmm.
By the time I make a read call, which went here, and it does not has got that last read on thing. So there is a possibility to be able to read it again.
So yeah, I mean, like on the consumer side, like there is a chance if that last read on was not replicated to followers, there is a chance another consumer might read the same message.
Or is there a better way to avoid that, some kind of a lock or something?
I don't think we need to go, because we only said at least once, right? Not exactly once.
Okay.
Can we use some sort of a, say, like write through cache and always read from the cache?
But cache, you cannot guarantee the durability, right? But what do you do when you write to the cache?
What I'm saying, that write through. So as soon as you will write, it will write the database, and you will read only from the cache, not from the read replica.
I think, but
distributed.
Cache can again have stale information. So how do you get over that?
Or do we want to maintain a separate map, like we write this message already, something like that?
I think if you want to go for exactly once, maybe you want to use the leader for everything.
So okay, let's as we already agreed that we may deliver a message to multiple consumer, right? So
Yes,
then what
yes,
is the
agree.
issue here?
No,
I mean, like that's fine, but like I think we are good for at least once. But like,
Yeah.
what do we need to do to make it exactly once? That's what we are trying to.
not exactly once. Within the time when we told like it would be invisible. That time also somebody was able to read the message. So that is the issue I'm highlighting. So I told like this message is read and it is invisible for 30 seconds, and still some other consumer able to read that.
Yeah, I think it's okay. I mean, like.
Yeah, so
because
that is
we're-
fine. I mean, some message may be delivered to 2 consumer or more than, right?
Because we have, I mean, like because all consumers are adhering to idempotency, so I think we are still good, right?
We should be good, but interviewer could grill on that. That's what I'm trying to say. Let's say our we are now going really deep dive, so that's what I was saying. Like I only have a
Hey,
read.
as soon as you decide that it has to be invisible, why don't we remove it from the database and put it in another store? If we decide that for some reason that consumer was not able to process it, we can put it back on the database again.
No, so the question is the same with this design. The question,
We are talking about leader versus followers. Like, I mean, like leader got this update, but it hasn't reached to all followers. If the consumer reads from a follower instead of a leader, that's where this problem comes.
Or we might do something like a different kind of a design where we can have a quorum. But I think for now that is outside the scope of this discussion.
So if a leader did not, suppose leader was not able to deliver, right? Then follower will not read that message unless the timeout happened, right?
No, let's say there is no timeout yet.
I see. Okay.
And
so that's fine, right? After timeout, that message will come and follower will pick it up. So basically, that message is kind of locked for that time.
So the question is, we read the message, and then the write happens on the leader. It asks to make the timestamp something current. It hasn't reached the follower yet. It's not replicated. And same time, we made another call of read, and we were able to read the message. Did you get that thing?
I see.
So between this replicates and we try to read a message, there is a possibility the consumer will be able to read it.
So we are saying that the leader and follower both have a different replica. They both read from different replicas, right?
No, Bhavesh, what actually a same point is that let's say a consumer comes and we deliver the message, and now we have to update that message in the database, right?
Yes.
So as we are following using the architecture of a single leader, so write will hit the leader. And now, and we have to have these few read replicas. So now another by the time these replica were not updated, and in between the another consumer comes and read the message from these read replica.
I see what you're saying.
That message was not updated yet on that read replica.
I see. So
could be a corner case. We can skip that, but I thought something.
Yeah, I think we need to revisit that because this will always happen, right?
I mean, that's a trade. I mean, we definitely. I mean, there may. We can say that okay, that is a trade.
This can happen even with the same consumer, right? So it's not guaranteed that the followers gets the replication done at the same time. So even if the consumer, the next read when it happens, the same consumer can get into the same problem. Not necessary that you are multiple consumers here.
Okay. I think I would need to rest the conversation here. We can high-level visit whether we're able to complete things which we have decided. Yes, asynchronous processing at least once. We are not tracking. Okay, we have this acknowledgement. We have how many times a message could direct. We have that setting also. How invisible also we are doing. This was V2, we don't care. Lifetime is also here. And size out of order, anyhow, it is out of order. And then this is kind of outside the system, but yes. So I think we covered pretty much most of the scenarios. Unless we want to discuss something else like single point of failures or bottlenecks.
Yeah, I think the bottlenecks is good to discuss. So one of the things that we discussed last is still I mean, like it can happen for single consumer or multiple because we are using this single ladder. And I mean, like we don't have an end-to-end full picture from producer to consumer, but like I think we covered the key part. So. Okay.
So what else
I
is
think
left here,
there
Asim?
is a cleanup process which we missed, I think.
Mm-hmm.
So Asim,
Sorry, go ahead.
in the grand view, right? So every time we go in this kind of things, we need to keep a timeline of what are the areas left and what is being completed, correct? And so should we, are we tracking anywhere? Like, we went from the high level, then we went into the queues, right? How the polling needs to be done or how the queue needs to be designed, services. And now we are designing the backend database. So anything else, we need to come up with a list so that we know that how much more is left and what is done. If we are just given 45 minutes or 1 hour, right? How much should we go in detail?
So basically, details is like what we did right now. We did with high level. Okay, again, sorry. Let me put in this way. If I have to do high level backend design and how the things will be read flow, covering the key scenarios, and then deep dive on one individual topic. So deep dive we did in terms of how the things will get replicated. And after that, I think we were right on discussing on the single point of failures and bottlenecks. I see a bottleneck here. If this component doesn't scale well, if you're writing so many things, it couldn't scale, or it could be like we have discussed some hot partitions here.
Yeah.
That could be a bottleneck. Like all the messages are going to one queue. You have 10 queues, but we are only using one queue, and then everything will end up in one partition. But Naga mentioned that we can do some kind of salting, where add a salt and try to make your partition key more generic, so we can spread messages across. So I think bottleneck single point of failures, and then validate the requirements, what we have covered and what we could not cover. So I think that should be good.
Yeah, we cannot cover everything, every aspect.
Yeah. No, I agree now. So my point was, we need to come up with a template, right? How much is left, and in this topic we dealt into many topics. We went into details, right? Which is very good. We don't know which one the interviewer is going to ask, correct?
Yes.
So we went into many details, which is very good. But what else is left in this that we want to discuss? We can have that in the left side points or something like topics that we need to address, and then we can dig into that in the interest of time.
Yeah, I mean, like definitely we can jot down, but like I don't think everyone will have the patience now. Maybe we can do a follow-up session.
Yeah.
So yeah, that's what I'm trying to say. Like we can conclude this. If any team has to also think in that way, if any team has to do this queue thing in real world, they won't be able to come in 2 hours. They will take at least 2-3 days or a week to do a design.
Yeah, it's a week's thing. Yes, what we are doing in 2 hours is actually a couple of weeks. You have to plan everything, and also it depends on whether the framework is already available and are we the consumers, or are we creating the framework for everyone to consume, because it's an open source, right? Every company has to build this, and we all are developers or engineers or architects, right? We have to build this in each of our companies. Uh, so this is very relevant, and we'll take more time to it.
Okay, shall we stop the recording then?
Okay.
Yeah.
Yeah. Thank you all. Like, let's